So everyone's on C24. Open up the note guide. It looks like this. The notes on 4.2. Scroll down a little bit on the first page and have this on your screen. It says the properties of rational exponents. Okay? You got that, Diaz?
Yes, sir.
Rocking it, rocking it. So the Rocha's got this? Almost. C24. The note guide on C24. Dominguez, rocking it. Good job. So you have a piece of paper in front of you and this in front of you. All right, here we go. So, I'm hoping, I'm not sure if it's the case, I'm hoping this kind of looks familiar. Let me copy and paste this puppy. Oops. Yeah. Let me paste it to my board. Does this look familiar to you, Ms. Diaz? Look at these property names on the left, product of powers.
Yes, it does.
De La Rocha, does that look familiar to you, what's on your screen, this stuff?
No.
Okay, how about you, Dominguez? Does it look familiar? This was actually the very first, right. The second week of school after orientation, that first lesson of math, I printed this out for you. And you've already gone through this, but what we're doing now, this has to do with rational exponents now. We just did normal exponents the first week of school. Now it's rational exponents. In other words, exponents that are fractions. Look at these fractional exponents here. 1/2, 3/2. What this is trying to say is, look, everything you know about exponents will work even if they're fractions, is what this is trying to say. So you already know, look at 1, 2, 3, 4, 5, 6, 7 rules. You guys did a flip grid on this. You guys told me all the rules. I think that was the very first assignment I gave you.
Yes.
And so this is, look at, all this is saying is, look, all those rules you know, they work for fractions too. Done. Talk to you later. That's the lesson for today.
All right, done.
Okay? I mean, that's all we're going to do today. Is everything you know about exponents works for rational exponents too. Now, when I say rational, that's just a fancy schmancy word for a fraction. So any exponents that are fractions, all these 7 power properties work too. That's it. Let's get into some examples. We're done. You post a Padlet, you pick one, and you could tell me you can do it on Padlet. You're done for the day. Start studying for tomorrow's quiz or work on anything you owe me. All right, here we go. Now, the notes that we're going to take, you can do it on the piece of paper in front of you, or you can do it on Cami, on this note guide. It's up to you. You decide. I don't make those decisions for your personal life. Here we go. Let me scroll down. We're going to do these 4 examples, and we're done with our notes, ladies and gentlemen. So you can do these notes on Cami on this note guide or on a separate sheet of paper. We're only going to do 4 problems for today. And then you're going to post one to Padlet. Again, you're on your piece of paper, you're going old school, or you're just doing this on Cami. These 4 problems, it's on your note guide. You choose.
Do they just show word?
We're taking notes right now, so. I'm not sure if that answered your question. Here we go, De La Rocha. You can go Cami, or are you going old school?
Paper.
You haven't written down. Write it down. Number 1. Old school or Cami? Here we go. Number 1. Diaz, old school or Cami?
Old school, mister.
Nice. Let's do this. I got some stuff in parentheses here, raised to powers, and then I got a power outside. So that looks, let me look at the 7 rules here. That looks like, oh, it looks like this one. Looks like this rule, look at it. If you have stuff in parentheses, you can take every item in parentheses to the power outside. It's kind of like a combination of the 3rd and 2nd, because look at the 2nd has to do with power raised to power. You multiply the exponents. So it's kind of a combination of both these, the 2nd and 3rd. this first example. So what I'm going to do is, watch this. I'm going to write 2 to the third, but then I'm going to raise that to the negative 1/3 power. So multiply that by negative 1/3. Because power to a power you multiply. Times 3 to the third power times negative 1/3. I trust I'm writing big enough. I'm not sure if you can read my chicken scratch. Let me write a little more clearly here. Let me make my marker a little more thinner so I can, negative 1/3. Here we go. So I took the third to the negative 1/3 power, and that's right here. I'm multiplying this power to power. I'm taking this third to the negative 1/3 power, and that's right here. You multiply the powers. Or I should say you multiply the exponents. So now we're going to go back to junior high school. How do you multiply fractions? That's way back in junior high. What junior high did you go to, Diaz?
Marshall.
What junior high did you go to?
Marshall.
What junior high? Okay, let's take a trip back to memory lane, junior high school. Thank you, boss. We're trying to go back memory lane of how to multiply fractions.
Okay.
Because these exponents you got to multiply now. So here we go. Let's see, a whole number of 3 times a negative 1/3. What can I do with that 3? Think back, Marshall. How do you make 3 into a fraction?
Put it over 1.
Thank you! Sorry. My coffee's kicking in here.
Excited too.
Look at that. Times. Let's make this into a fraction again also. 3 over 1. Okay. Rocking and rolling. Rocking and rolling. Okay. 3 over 1 times negative 1/3. Help. Let's name. Okay. Let's
Give me a second rumor.
help. Middle school in Chino, Marshall Middle School over here. What do we do? 3 over 1 times negative 1/3.
That's negative 1.
Negative 1. What you do? Tell me. Just for
Well,
the.
it's because 3 times 1 is 3.
Right, numerator times numerator, exactly.
And it's still negative.
Good. So numerator times numerator, denominator times denominator.
It's 1 whole.
So it becomes 3 times negative 1 is negative 3. 1 times 3 is 3. You with me, De La Rocha?
Yeah.
Got that puppy.
So let's see. Negative 3 divided by 3. Negative 1. And it seems like I'm going to have the same thing over here, but with the 3, huh?
Yes, sir. 3.
Yeah. There's another rule of exponents now. Negative exponent rule. Let me refresh myself from way back the first week of school. Negative exponent rule. Oh yeah, that's the 4th one. Look at it. Remember that? You do the reciprocal.
Yes, sir.
You with me, De La Rocha?
Yes.
Watch this. So this is 2 to the negative 1 power over 1. This is 3 to the negative 1 power over 1 also. So I'm going to reciprocate. So this becomes then 1 over 2 to the 1 power. But I don't have to put the 1 power because everything's the 1 power. And I got 1 over 3 to the 1 power. Wow! Now I'm just multiplying 1/2 by 1/3 in the end.
Equals
Hit it.
1/5. 1/6.
Numerator times numerator, think Marshall Middle School, think Chino Middle School. Numerator times numerator, denominator times denominator, so that's going to be 1/6. So look at where we start off from. This nasty expression up here ends up becoming, in the end, with all of the rules of exponent, just 1/6. It's crazy. Now this is not going to be on the quiz tomorrow. This is going to be on next week's quiz because we're just starting it today, so don't stress out. What's going to be on the quiz tomorrow is the equations we did for warm-up. That's everything we've done this week, just so you know. Thank you. Yes, I like the thinking, Dominguez. I like how you're thinking. I can see you're focused, concentrated. I'm not seeing that game face on you. You're like, focus right here. Give me some questions.
Tired.
Aww.
I got a teddy bear back there. Snuggle up and take a nappy.
All right.
Just kidding. He's all right.
Woo! My sugar's kicking in.
Let's try the
Anyway,
second one. We're good? Dominguez? De La Rocha, we're good? Let's try the second one now.
Mister, are you laughing at me, mister?
No, it's funny. No, he said. All right. So I'm asking myself on number 2, self, what rules can I use from exponents? Well, I'm looking at that numerator. Looking at that numerator. What exponent is that numerator raised to?
None.
So it's raised to the what then? If it's
1 power.
The 1 power, huh? It's automatically the first power is nothing there. So now, I'm looking at this. I'm saying self. Self, look at this problem, self. Self, you're dividing. So self, what rule involves division? Well, let's see. Up here, the rule that involves division is this one and this one only. I'm looking at the quotient, look at this, the 6th one right here. If you have the same base and you're dividing, same base and dividing, that's precisely what we got, right? Look at, we have a base of 10 here and a base of 10 there, and you're dividing. That sure looks like that situation. It looks like a quotient of powers situation. So what it says is, look at, all you got to do is subtract the exponents. And we'll be done.
So what, we put 10?
To the, go ahead, yes.
10 to the power of 1 minus negative 4 to the power?
Give me that. Give me that.
4.
Give me that. So this becomes then 10 to the first power minus, watch this now, that's a negative 4/5 power. So I'm going to minus a negative 4/5. Yikes. That looks nasty, but that's just Marshall Middle School stuff. Chino Middle School over there.
Where are you starting at? I don't know what
He's
you're
on number 2.
saying. I know, but it's on number 1 problem, no?
Yeah, that's all number 1. We're done. So we're now on number 2. Let me
Draw a line, mister.
Thank you. We're on number 2 now. You with me, Dominguez?
So that gets me. Let's see.
Let's go back to memory lane now. How the heck do I subtract fractions? This might be the end for some of you, because that's really difficult for a lot of students, is subtracting fractions. But let me rewrite. So here you go. 1 minus a negative 4/5. Whew. Do you guys remember when you subtract fractions and stuff, you have to get common denominators? I'm not sure if you remember that. What I end up having to do is I have to take 1 right here, and I have to rewrite it with 5/5. So this is really now, I took the 1, I made it 5/5. 5/5 is 1/2, but now I can subtract the fraction because I have the same denominator. So I rewrote 1 as 5/5. You can write the number 1 in an infinite amount of ways. You can write the number 1 as 1/1, 2/2, 3/3, 4/4. So this is really 1 now minus a negative 4/5. Now, how do I subtract a negative number? Well, remember, you change that. Rocking and rolling. So I really have then 10 to the 5/5 plus 4/5 power. 5/5 plus 4/5 help. What's 5/5 plus 4/5?
Well, technically.
Marshall
speaking,
Middle School, Chino Middle School over there.
19.
Whoa, that was scary. One more time.
It would be
You were there though. It's funny because you're there. What?
10.
9, close.
9 to the
over
5th
10.
power.
9/5 power.
So 10 to the
9 power.
1/2.
Hold up that. Let's just do the 5/5 plus 4/5. That's all I'm asking right now.
Well, it would be 9 to.
It becomes 9/5.
Yeah.
Got it. You just add the exponent or the numerators. 5/5 plus 4/5 is 9/5. So far so good?
Yes, sir.
Okay. We're just adding the fractions on. And the reason why we're adding the fractions is because this was 10 to the first power minus a negative 4/5 power. We have the same base. We're using the sixth rule. If you have the same base and you're dividing, you subtract the exponents.
I see why you did 5 though. 5/5. Because of the denominator and 4/5 is 5.
Exactly. You need, in order to add or subtract fractions, right, you need a common denominator. Good. Very good. Okay. Rocking and rolling.
Would it still be the same if you put 10 to the 1/2 4/5?
So it'd be 1 and 4/5, yeah.
That would be the same thing. But
You
that's
could-
more complicated.
Yeah. Let's just stick with our rules for now. So here we go.
Alright, that could be.
Okay. Here we go. Any questions so far? We're not done yet. What we're going to do now is we're going to take this, watch this. What does 9/5 power mean? That's Monday's lesson. That means the 5th root of 10 to the 9th power. That's from Monday.
That's for the moment.
Right? So I'm going to type that in my calculator now.
I'll type it in my calculator.
The 5th root of 10 to the 9th power. I like that. I need one of those. I like the patriotic. It's awesome.
I need a break, man. I've been working on this grant,
Uh-huh.
so I need to like relax my thoughts.
Gotcha.
Because it's just paragraph and paragraph of writing of why I want the money. How am I going to use the money? Where's it going to go?
Gotcha.
Good morning, Mr. Molina.
Is that you, Natalie?
Yes.
I didn't realize.
5th root of 10 to the 9th power. That's easy sleazy.
63.
So again, this, when I made this movida right here from this to that, that's all Monday. You learned that on Monday. Go back to C21 and review that. That's Monday's lesson. The numerator becomes a power and the denominator becomes the index. That's Monday's lesson, you guys. So now I'm just going to type this garbage in my calculator and see what we get. 5th root of 10 to the 9th power.
63.11.
Nice. I think you're right. Let's see.
Now you need to put your parentheses first, mister.
Forgive me!
You're forgiven.
What's it to?
10.
10?
Other parentheses.
Matter with me? What's the matter with me? Don't answer that.
I can't answer, mister. I'll have to call your wife now.
To the what power?
To the 9th power. Well, what's wrong with your husband now?
She's like, how much time you got?
63.11 because the 9 is going to convert that 0 into a 1 and the 5 is going to convert the 9 to a 1.
So it'd be 63.10, not 11. But I like your thinking. That 9 becomes a 10, so there's a 0 there and the 1 carries over.
Mm-hmm.
So 63.10.
Wait, but doesn't the 5 going to affect the 0?
So the 5, so we're going to run the nearest hundredth, the second decimal. I look at that 9, I look to the right of it, that's 5 or bigger, so this becomes a 10, but the 1 carries over. So it's 63.10. Here we go. 63 then. 0.10, approximately. Forgive my squigglies.
I thought it was a Z. Alright. Fourth focus. Oh, this looks funny.
What do you guys think?
What is that? 63?
0.10. Forgive me. Looks like Greek letters or
Let's
something.
say you need to drink some more coffee.
That's a great idea. Let me pause this and. This looks like a combination of the 7th one, right here, and the 3rd one, the 2nd one, the 2nd and 7th. Because you're going to involve power to power. Because look, you got the 5th to the 1/6, you have to multiply those puppies, the exponents, and it involves division inside parentheses. So everything in division, in the parentheses that's involved with division, will be raised to the power outside. So it's really a combo of those two. Let's do it. So I'm going to rewrite this as 52 to the 5 times 1/6 power. Right? Because look at power to a power, you multiply those puppies. Absolutely. Good idea. You're welcome. So 52 to the 5 times 1/6 power
Times.
divided by, yeah, 4 to the 5 times 1/6 power. I'll stop there. Questiones.
No, you don't need it.
So it's going to be 52. So 5 times 1/6 is going to be 5 over 1 times 1/6 over 4 to the 5 over 1 times 1/6. Remember, we're just multiplying fractions now, just like we did on the first one. Okay, so here we go. So this is 52
52.
to the what power?
5 over 6.
Good, to the 5/6 power. Oops. Over 4 to the 5/6 power.
So then,
So it looks like I got the numerator and denominator.
and you can multiply those together, right? The powers.
Well,
Oh wait, no, subtract them.
that's if we have the same base. We don't have the same
Oh,
base.
right.
So we have the situation here. We have the same exponent, but not the same base. I'll wait till they're done right in here. Because I'm gonna do an important move right here that I haven't done before, and it might scare you guys, but it shouldn't be that scary.
Man, whoever made this. I get them like $1,000.
Is that good, huh?
Mm-hmm.
What's that one called?
Chocolate Mexicano frappe.
Frappe.
So it's the abuelita, the chocolate de abuelita,
Oh, that's good.
and that's that.
Interesting.
Right.
That's good stuff right there.
Yes, sir.
All right. So look at this one move I've never done before. Put your seatbelt on. Same exponent, but not the same base. So look what I'm going to do. De La Rocha, everyone's paying attention, but come on, man. Watch. I'm looking at these rules. Look at right here, watch. Look at same exponent here, but not the same base. That's the same as this here, this situation.
Oh, I see.
So I can go reverse and put this stuff in parentheses. Let me say that again. Let me highlight it a little bit better. Same exponent, but different bases being divided. You can go from here to here. You can take the things being divided and put them in parentheses and then put the same exponent on the outside. This way you can do the division first before you take the exponents. So in other words, watch. I'm going to do that right here. I'm going to rewrite this now. I have the same exponent but different bases. So look what I'm going to do. I'm going to put the division problem right here inside the parentheses. And I'll write the whole shebang to the 5th, 6 power. So in other words, I use the 7th power property, but in reverse. So 52 divided by 4, I want to say that goes in evenly. Let me get my calculator here.
It does, the 10 into 13.
Nice. 52 divided by 4 is 13. Very nice. So look at this ends up becoming then in the end. Look at, I'm doing what's in the parentheses. 52 divided by 4 is 13. To the 5, 6 power. So 13 to the 5, 6 power is the same as, watch this now, the 6th root of 13 to the 5th power.
Gets you the same thing. So it gets you 8.5.
Again, this is Monday's lesson from 13 to the 5, 6 to the 6th root of 13 to the 5th power. That's all Monday.
Okay.
So I'm going to type that in the calculator now, 6th root of 13 to the 5th power. There we go. 6th root of 13. Again, I forget the parentheses like a doofy.
Come on, mister, pull yourself together.
To the 5th power, huh? Yeah.
Yes, sir.
I'm going to run the nearest hundredth, so it's 8.4.
8.50.
Wait, to the nearest hundredth. 8.40.
48.
Yep, 8.48. Approximately 8.48.
48. Damn, these are a lot of steps.
All right, I'm done for that. I'm not going to go to the 4th one. I want to give you some time to post to Padlet.